Hello ladies and gentlemen, we're going to do 13-2B today. More fun in our chapter on trig. We're going to do arc length, area of a sector, and trig ratios. The first thing we do have to do though is do some review on geometry terms, and then we will start managing some math. And I have a coffee break. It's yummy. Alright, so let's talk about a circle. Almost a circle. It's not too shabby. Alright, so that's my center of my circle. And this is going to be called a central angle. Okay, so I'm getting out a handy dandy highlighter. Alright, so I'm going to extend the rays of my angle a little bit. So we're going to call angle A central angle. And it means that the vertex of that angle is at the center of the circle. That angle intercepts an arc, okay? So we'll call that arc A, okay? So that is the intercepted arc. There's two different ways to measure an arc. I can measure an arc in degrees, which is what you did in geometry. I can also measure an arc linearly. That's a weird word. I can measure it linearly, which means if I took my little chunk of an arc and I kind of stretched it out, then I could measure it with a ruler. So there's two different ways. If I talk about measuring an arc in degrees, I'm talking about its rotation. Or I can measure it linearly, which means I could kind of take my little arc and flatten it out and measure it with a ruler. Okay? So I'm going to stick a little theta there too. So in geometry, you learned that the measure of angle A is equal to the measure of arc A. Okay, so those two are equal. But in trig, what we're going to talk about is we're going to talk about the arc length. Okay, which means I want to smash my little arc out and measure it linearly. So it's going to be done with a handy dandy formula called S is equal to R theta. So instead of taking my little arc and smashing it and measuring it with a ruler, I can use a handy dandy little formula. In the formula, the R represents the radius of the circle, and the theta is going to be the central angle. The caveat is it has to be in radians, and I'm going to put it in big old honking capital letters because this is the piece that people tend to forget. So if you're given an angle in degrees, you have to convert it to radians before you can use this handy dandy formula. And then, let me get out another color. Oh, what color shall we use? Let's say pink. The pizza pie, this little guy, so I'm going to color, this little guy is called a sector. Okay? So the pink guy is called a sector. And it is a slice of the circle, and I can calculate the area of that as 1/2 r squared theta. All right, so I can calculate the area of my little sector. Okay, so those are our two handy dandy formulas, and again, r is equal to the radius, and theta is the central angle, and it has to be in radians. Always, always, always. So let's do a couple of little examples. I'm going to tip my little thing a little bit because it's giving me kind of a weird angle. Alright, so the first example says to find the arc length and the area of the sector, okay, my little pizza pie slice, with the given radius and central angle. Alright, so I'm going to do a couple of different problems. The first one, the radius is going to be 4 inches and theta is going to be pi over 6. Okay, so that's your given information. So I'm going to do my arc length first. So the formula is S is equal to R theta. My radius is 4. My theta is pi over 6. So I'm going to do that math on my calculator, so it's going to be 4 times pi divided by 6, and I'm going to get 2.094 inches. So that would be the length of the arc. When we do the length of an arc, we usually do not leave pi as part of the answer. We actually use the pi button on our calculator and get its numerical equivalent. So now if I calculate my area is 1/2 r squared theta. So here's the half. The radius was 4 squared, and my theta was pi over 6. So I'm going to end up with 1/2 times 16 times pi over 6. Okay? And if I do that math in my handy dandy grapher, I get that my area is 4.189 inches squared. And remember, area is a square unit of measure. Okay? All right, so I'm going to do another problem, same directions. So this time I'm going to be given that my radius is 18 meters and my angle, theta, is 25 degrees. Well, that presents a wee bit of a problem because theta has to be in radians. So before I can do the problem, I actually have to convert my angle to radians. There are 180 degrees in pi radians. And because my answers are going to be in decimal, I'm not going to leave the pi in my solution. So when I do my conversion, so I multiply 25 times pi and I divide by 180, I get 0.436 radians. Okay, that's a 0. All right, so now I can do my two formulas. So S is equal to r theta, which is my arc length, which is going to equal the radius of 18 times 0.436. And when I do that math in my handy dandy grapher, I get 7.854 meters. Remember, we're talking about a linear unit of measure. Okay, and then if I calculate the area, its handy dandy formula is r squared theta. So I'm going to have 1/2 18 squared, and then my theta was 0.436 radians. When I do all of that math on my handy dandy grapher, I get something. Where did I do that math? There it is. Turn the page. I get 70.632 meters squared, and that's the area. Notice that I'm including units and I'm identifying my answers. All right, so that was fairly simple. The next thing that I need to show you, because we'll start using this on your grapher, are the two different modes for using the measures of an angle. So your mode button is right there. See, it says mode. I'm going to hit mode. And notice right here on the third line, I have radians and degrees. It will be your responsibility to make sure that your calculator is always in the correct mode, because we will now, for the rest of the chapter, kind of be flipping back and forth between radians and degrees. So you always want to make sure that you are in the correct mode. All right, so that's how I do that on my calculator, and then I'm good. All right, so I'm going to put that off to the side for a sec. The next thing that happens is we start talking about this lovely word exact. And exact means you're going to use your special right triangles, okay? It also means, can't write, no decimals. Alrighty. Okay, so before I do this, I'm just going to remind you of your special right triangles, okay? So if this is a 30, 60, 90, opposite the 30 is going to be a 1, opposite the 60 is a radical 3, and then the hypotenuse is 2. Okay, regardless of where the 60 is. So if I rearranged it, and I put my 60 down here and the 30 up here, opposite the 30 is 1, opposite the 60 is radical 3, and then the hypotenuse is 2. If I have a 45, 45, 90 special right triangle, so if this is 45, 45, remember that the legs are congruent. The legs are going to be 1, and the hypotenuse is radical 2. So those are the ratios that you need to remember. You need to memorize that information. The next thing that you're going to need to manage that exact word are some angles in the unit circle. And every teacher teaches this particular section differently. This is my particular favorite way to do this, so you're stuck with me, so there you go. So remember that this was 0 or 360 degrees. This is 90 degrees. this is 180 degrees, 270 degrees, and there's my 360. So you need to know those 4 units of measure for your angles. Now I'm going to do it in radians, okay? And I'll do it in a different color, maybe that'll help. This is 0 radians, okay? This is pi over 2 radians. This is pi radians. This is 3 pi over 2. And then all the way back around is 2 pi, okay? You will have to memorize those values. And I'm going to do the other ones in pen so it's a little darker and easier to see. The other ones that you're going to have to memorize is 30 degrees, and that is pi over 6 radians. The next angle would be 45 degrees, and that's going to be pi over 4 radians. And then my last one, I'm going to bring it out here so it's not stuck, is 60 degrees, and that's going to be pi over 3 radians. You must memorize all of that information because we're going to use it for the rest of the chapter, and I'm going to expect that you know it, and I will not give you this information. You will have to know this information. Excuse me. All right. So now we're going to take that information and start doing some examples. So I want you to evaluate the trig ratios by hand if a special, and by special I mean is it a multiple of one of our special right triangles, or by calculator if not a special. Okay. If it's a special, what you can do by doing it by hand is you're going to find the exact coordinates. If you're doing it by calculator, you're going to get a decimal. And remember, exact means no decimals. So the first problem is the cosine of pi over 3. So I want to find the cosine of pi over 3. Pi over 3 is 60 degrees. That's one of our specials, so I'm going to draw the picture. This is imperative that you do this. So here's my 60-degree angle, okay? And it's going to create a right triangle. So if this is 60, this is 30. Opposite the 30 is 1, opposite the 60 is radical 3, and the hypotenuse is going to be 2. So if you'll remember, the cosine is equal to the adjacent over the hypotenuse. So the cosine of pi over 3 is going to equal 1 over 2. There you go. That's pretty easy. Okay? Anytime I have a multiple of one of our specials, a 30, 60, 90, and that's going to be my pi over 4s, my pi over 3s, my pi over 6s, those are going to be my specials. I have to do that by hand. And doing it by hand means that I draw this diagram, I label it, and then I can do my ratios. Okay? Number 2, I want to do the sine of pi over 4. Pi over 4 is again one of our specials, so I'm going to do it by hand so I can find the exact coordinates. I'm going to draw my little picture. Pi over 4 is 45 degrees. Okay? So this is pi over 4, so that means that the legs are 1 and the hypotenuse is radical 2. The sine is equal to the opposite over the hypotenuse, so the sine of pi over 4 is going to be 1 over radical 2. I can't leave radicals in the denominator, so I multiply by radical 2 over radical 2, and so I'm going to get radical 2 over 2. So that is the sine of pi over 4. The next example, I think the last example, I lied, I have a couple more. Okay. The next example, we're going to do the tangent of pi over 6. Pi over 6 is a special. It's a 30-degree angle, so I'm going to draw it. Okay. So here's my triangle. This is the 30. This is 60. This is my pi over 6. It's in radians. Opposite the 30 is 1. Opposite the 60 is radical 3. And then this is 2. So my tangent is opposite over the adjacent. Okay. So opposite is going to be 1. Adjacent is radical 3. And that's going to be the tangent of pi over 6. Slight problem because I have a radical in the denominator, so I multiply by radical 3 over radical 3, and I get radical 3 over 3. And that's my answer. All right. But what if I need to evaluate and something's not special? So for my next example, I have the cosine of pi over 8. Pi over 8 is not a special because it's not a multiple of pi over 3, pi over 6, or pi over 4. So that means I get to use my calculator. Notice though that they gave me the angle in radians. So that means that my calculator, see if I can get it where there's not a glare, has to be in radians. So the first thing I'm going to do is I'm going to go to my mode and I'm going to put my calculator in radians, and then I'm going to do the cosine, and I'm going to do pi divided by 8, close, go, and then I'm going to write down that decimal. So the cosine is 0.924. If my answer had not been in radians, I would not have gotten the correct answer. Okay? So you really want to pay attention to how they're giving you the math. The next one is I want to calculate the tangent of 3 pi over 7. Well, that's in radians. I just put my calculator in radians, so I'm going to do the tangent of 3 second pi divided by 7, and it's 4.381. Okay, so I'm going to have 4.381. All right, the next example is the sine of 48 degrees. And again, 48 is not a special, neither is 3 pi over 7. But now I'm back in degrees, so I have to go back to my mode button. Okay, pull it down so you can see it. I need to put it back in degrees, and then I'm going to do the sine of 48, and I get 0.743. So not too bad. Alrighty, so you will always have to be very careful with the mode button on your calculator, and when I talk about specials, it's going to be multiples of these angles that you need to memorize. So what I would recommend that you do is that you give yourself an index card and you draw that unit circle or that image that I did before, label the angles that I said you needed to memorize, and keep that with you a lot where it's easy to find so you can use that as a reference as you learn that information. All right, now let me give you your problems. Okay, the first set say to calculate the length of the arc and the area of the sector, oops, that's supposed to be an S, of the sector given the radius and theta. Okay? All right, number one, your radius is 5 meters and your theta is pi over 14. Okay? Number two, your radius is 10 feet and your theta is 93 degrees. Okay? Your second set say evaluate the trig ratio, giving exact answers. And remember, exact means it's a special, and it means do it by hand, which means draw the diagram, draw and label. Label, 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 if possible. Okay. Number 3 is going to be the cosine 49 degrees. Number 4, the sine of pi over 3. And number 5, the tangent of pi over 4. All right, let me move that up so you can see it. Sorry, that was my bad. So there are your problems. Good luck with those. They are not too difficult, and I will see you tomorrow.